Alright, now it's time for video. I believe this is the fourth one. I retyped all the code I lost when I force quit processing. It wasn't much, so it didn't take long. And I dumped our Dave amount down to 64, because that is a much more manageable number. I don't have to worry about overflowing the RAM or it running slowly. Anyways, now we're going to make it more interesting. First thing I'm going to do is we're actually going to include more variety. As you can see, I have a picture of all of the Homestuck friends lined up on a nice grid, with the exception of, I think his name is Tarvos and Gamzee. They didn't fit, so they're not on the grid. So, let's get started. Right. So first thing we're going to do is we're going to switch which image is loaded. It's called andfriends.png. And friends. So now it'll kind of be all clustered. Yeah, that looks terrible, doesn't it? That's not what we want. Fortunately, that can be fixed by adding a few extra values at the end of the image tag. These four numbers represent where on the picture to cut from. So if I take my rectangle tool and let's say we picked, well, let's actually try to pick Tarvos. So, yeah. So this is location 71, 299. That's where it is on the picture, and width we're going to do the same as always, 84, 100. Hit play, and that is awkward. It's not what I expected. Am I doing it right? Or did I mistype it? This may be another one I have to skip. Let's look up p-image. Alright, so this isn't how we're supposed to do it. At least I don't think so. ImageDave.get. Let's toss these numbers into here and see if it likes that instead. Yes, that is more what I was expecting. At least I think it was. Maybe it's a little on the small side, but that's okay. So instead of grabbing the image directly, we're using the get method and only grabbing this section of the image. And then we're giving it XY width height. Let's change this to just, well, let's leave it image day for now. We don't need to get confusing. Anyways, I was going to make it pick one from the grid. So let's add a new variable. Int, we're going to call it ID. It stands for its identity. Then ID is a random number between 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now this will crash because it will say I can't convert a float to an int. What we can do is we can say int and then put it in roundies, and that makes it doable. No noticeable change because we didn't change anything visually. Anyways, so now we simply set the get rectangle to be the ID, and we multiply that by 84. So it will pick a random step between 0 and any value between 84. And as you can see, it's way... Oh yeah, that is why. It's because we scaled down the image in processing. So how big are you? Well, actually, let's just go by the grid size. So 214, 252. 214, 252. There we go. That's running considerably slower, actually. It's noticeably lagging on my side, probably because it's cutting the image every single time it displays it for all 64 Homestuck friends. There's a way around this, of course. Let's make a new array. Be image images equals new p image, and let's give it 14 spots. Images, or no, for copy paste time, images dot length. For loops are repetitive, and I accidentally did it twice there. So images I equals image Dave equals this dot get. Instead of ID, we're going to do I. This makes it so it cuts up all the images ahead of time, and then here we simply say images ID. We don't need to multiply it. There we go. Now we have varied Homestuck friends, and they are bouncing much smoother. Another thing that would make this more interesting would be to have some sort of gravity. Gravity's not hard to add, although I ran into some bugs when I did it last time, which I was able to fix. So let's just make a global variable. Let's name it gravity. And let's make it negative, let's make it 2. Need an equal sign in there. And here, we simply say Vx plus equals gravity. Except we need that to be Vy, because we don't want things to fall sideways. And there we go. Now they're all bouncing violently until they decide to glitch through the floor. We don't want them to glitch through the floor, and I've figured out why that's happening. It's a little hard to explain, but it's very easy to fix. So, first of all, I need to explain something quick. If statements can be drawn in 2 ways. There's the if, yada yada, and then stuff. But it will break if you try to do another line of stuff, because then it won't think it's in the if statement. That's when you bring out your curlies, and then you put stuff down in there. Now we're going to need to make all these if statements do 2 things. So which means we're going to have to convert them all to the big form. It doesn't look as nice, but it has to be done. What's happening is their vertical velocity is becoming less than the amount of the gravity. So inverting it doesn't make it positive anymore because it still gets subtracted by 2 or added by 2. You get the idea. So to fix this, we really only have to do it here. Y equals. We have to make sure it never falls. Oh, why is there a plus in there? Did I accidentally do that? Oh, I get it. Height minus 100. There we go. This will make it so that if it ever falls underneath the stage, it gets teleported back on top of the stage. Therefore, when they eventually lose momentum, they don't sink through the ground, they simply sit still and keep sliding. But right now, it's a nice screensaver, I guess, but it's not very interactive. So let's make it do something with the mouse. And that is actually very simple. We can do it within the display method. If mouse pressed, that will tell processing to check if the mouse has been pressed. It'll pretty much return a true or a false. If it's true, it'll do it. If it's false, it won't. And then let's make it set the velocity random every time you've held the mouse down. So they all go bouncing, wait for them to settle down a bit, and we click and it sets it random, but as you can see, it just kind of jiggled a bit. It doesn't give them enough oomph. So let's pump these numbers way up. Because the reason they're bouncing so much is because they're starting up in the sky. And now they're really moving. Sorry. But the reason they never slow down is there's no drag. And that's also easy to add. Let's make it 0. It needs to be a number that's close to 1, but not quite. So Vx times equals drag. Vy times equals drag. Oh, they don't want to move at all. It appears I made this number. Oh, I get it. Way too many zeros. There we go. I got that mixed up. So now they should slow down. Let's make the effect more drastic. Let's just do 0.9. They should almost come to... There they go. Now it's a party. Maybe a little bit bouncier. 0.99. That's closer to 1. And the obligatory, make it 1,000,000. And then this will conclude the tutorial series. Assuming it even works. Yep, it works. Kind of. We're getting like 1 frame every 10 seconds. Yeah. Let's drop that value a little bit. 10,000 is still reasonably high, but it should run much smoother. There we go. Now we have a whole crowd of them. Anyways, thank you for watching this series if you managed to stay the entire way through. Hopefully you learned a thing or two about the basics for programming. All of the techniques shown here can be used to make simple games or other various processing shenanigans. Pretty much variables, if statements, and loops. That's all you really need to know. Well, classes help. Some of my bigger projects have upward 10 classes. Here's one I'm working on in C++. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 11. Lots of classes, as you can see. That's quite complicated, and we won't get into that. I, sh I should have put one Waldo in there. That was a missed opportunity. Oh well, you can do it if you're ever so inclined. Well, I guess it's the end of the series. I'm gonna hit the stop button.